Hello everyone, in today's video, I'm going to talk about stepper motor VREF, the voltage reference. Voltage reference is a measure in the stepper motor driver circuit. It usually can be adjusted via a potentiometer. A potentiometer basically is a manually adjustable resistor. On Creality board version 4.2.2, it looks like a flat-headed Phillips screw. The VREF regulates the amount of electrical current delivered to the stepper motor. To make sure the stepper motor runs in a good condition, you need to tune the VREF so that the motor can generate the maximum torque while it does not get too hot. You would probably need to change these VREFs when you replace the stock motor, or you find your motor skipping step or running too hot. In my case, I've replaced the extruder motor with this slim pancake motor for fitting my afterburner mods. The reason I wanted to have a video about VREF is because it's difficult for me to find out the source of the data I needed. So I would like to share with you how I approached the issue, and hopefully it can help you if you are looking for something similar. Yes, you can find these values here and there and even the calculation formula, but no one tells you where these values and formulas are from and how they get them. It's always important for me to use first-hand data as the source of the truth. Let's jump into the hole and see how deep it is. The first thing I need to figure out is the stepper motor driver chips. I know it is TMC228 on industry version 2 board, but for confirmation purpose, I also verified in a modern firmware source code. You can see clearly it's TMC228, and we also see it runs in standard long mode. TMC drivers are developed by Trinamic Motion Control. By searching on their website, I found this datasheet with a VREF calculation formula. I was thinking with this formula, if I could find out the missing RSense and IRMS, then it would be very straightforward to work out these VREFs. The RSense, current sense resistor, on the Creality board version 4.2.2 is 150, which can be visually checked. But RMS current is a bit tricky. I could not find any detailed datasheet about the motor industry uses. The only information I can get is the rated current, which is 1.5, but it's from a store who sells it online. Let's assume 1.5 is the maximum current for now and see what we can get. The VREF is 2, according to TMC formula. If we put a 20% buffer here, it is then 166. It still seems to be higher than I expected. After doing some more Google searches, I finally found this recommended RMS current from Creality. Well, these are not from Creality official website, but it still looks promising to me. Because if I put these RMS current values into the TMC formula, I can get the same ones. In the process of searching TMC228, I found this doc from FISEC. It's a great doc, but I could not understand why it simply calculates the VREF using RMS times 1.4. Maybe this is their practical translation of TMC's formula. I then verified the VREF on the board. The readings are almost the same as the value from Creality's recommendation. Finally, I can go back to my case. What is the new VREF for the afterburner? Well, my new stepper motor has a rated current 1 amp. I assume this is the maximum current. It may not be the case. Putting 1 into the TMC formula, I get 1.8, is the VREF. That's pretty close to the stock eVREF value. That explains why the new motor has been running very well without any changes so far. But to play safe, I turned it down to 1. Well, the whole process is by no means of science, mostly because I could not find enough information for a precise calculation. I think that's why I see a lot of discussions on this topic. But with the information we can get, at least we have a baseline. Then we run some tests to make sure everything works great. That's what alchemy is all about. Engineering. Let me say it again. That's what engineering is all about. I hope experts can share more precise information with us on this topic in the future. Alright, that's it for today. Thanks for watching. Take care and see you next one.